Adolf Strecker, a German chemist, discovered a series of chemical reactions that produce an amino acid from carbonyls. Using ammonia or ammonium salt in this reaction gives unsubstituted amino acid. The classical Strecker synthesis gives racemic mixtures of alpha-amino acid as products. But several alternative procedures using asymmetric auxiliaries or asymmetric catalysts have been developed. The asymmetric Strecker reaction was reported by Harada in 1963, while the first asymmetric synthesis via chiral catalyst was reported in 1996. Let's make amino acid using Strecker synthesis. We're going to start with carbonyl and form this nitrile, and after that we're going to do nitrile hydrolysis, giving us our amino acid. Let's understand the mechanism. Here we're going to start with carbonyl. If I were to draw its resonance, that oxygen is going to be electron rich and that carbon is going to be electron deficient. So your electrophilic site is going to be on that carbon, and a good nucleophile is going to be that oxygen because it has those electrons to share. So we're going to introduce hydrogen cyanide to it. So that oxygen with electron pair, lone pair, is going to come in, grab that hydrogen and freeing that cyanide, which we'll use for later. Now ammonia is going to come in, right? Now you have protonated hydroxyl group. So that ammonia is going to come in, attack that carbon, which is a good electrophile, and it's going to push the electron density towards the hydroxyl, where you're going to get this. Now you have a protonated amine. So proton transfer will happen, generating this water, which is a good leaving group. So that lone pair on amine is going to come down and it's going to push that water out, which is going to give us this iminium ion. After that, the cyanide we generated is going to come down, attack on this carbon, right, which is an electrophilic site, and it's going to push that electron density towards that nitrogen, giving us this nitrile compound. And you also have amine to that. Now the second step is going to be nitrile hydrolysis. So we have an acid, right? Your nitrile is more reactive than your primary amine. So that's going to come in, grab that hydrogen, become protonated. Now you've generated an electrophilic site. So water is going to come in, attack that carbon, right? And it's going to break that pi bond, pushing that electron density towards that nitrogen. After that, you generate imine. Now you have this protonated water. So proton transfer will happen, which is going to give us this iminium ion, right? Now we have a water, right, in this reaction, which is going to act as a nucleophile. So it's going to come in, attack that electrophilic site, push the electron density towards that nitrogen. Now we get this. So we have protonated water here, amine and hydroxyl group. So proton transfer is going to happen. Your amine is going to pick up that hydrogen, right? Now you're going to generate ammonia or protonated ammonia. So your OH is going to want to, come down, make that carbonyl bond, right? And it's going to push out that ammonia, which is entropically favorable. And after that, you're going to generate this, which is a protonated carboxylic acid. Then the last step is just going to be deprotonation. So water will come in, pick up that, abstract that proton, giving us our amino acid. So that's all for Strecker synthesis.